Okay, fourth graders, gonna go through another science lesson with you. What we learned last week, I want to review from that. We talked about what causes day and night, and when we were doing that, I'm just gonna AV mute this for a second. When we were learning about what causes day and night, what really causes day and night is the spinning of Earth on its axis. Remember, an axis is, in real life, an imaginary line that runs from the North Pole to the South Pole. But on our globe, we have a real axis because we need something for this globe to spin on. And as we're spinning, how it works, if I can find my flashlight, is when the Earth spins, part of the Earth faces the sun and part of the Earth doesn't. And the rotation is what causes different parts of the Earth to be on the side of the sun. So rotation is the important word. Rotation is the spinning of an object on its axis. What we're going to learn about today, and I'm going to do my best to kind of teach you about this, is we are going to learn about the seasons of the year and why we not only have day and night, but seasons of the year. So what causes the seasons? It says not only does Earth rotate on its axis, it also revolves around the sun. Revolution is when one object travels around another. So the Earth goes around the sun, okay? While it's going around the sun, it's spinning and moving around it. The path of a revolving object takes is its orbit. Earth's orbit is shaped like an ellipse or a flattened circle. Earth's orbit around the sun takes 365 1/4 days a year. A couple things that I want to touch on here. When I was a kid, and this is not going to be a really great drawing, but we're going to say that's the sun. And here's Earth. Now, why this isn't a great picture is because Earth would be much smaller than the sun. In my picture, it's not. Got some green in there. Some blue. There you go. There's Earth. Okay? And I thought, it goes around the sun. It must just be a circle, like that, with the sun in the middle. Well, that's not true. That's not what it is. And even so, my circle isn't even. What Earth's orbit is, what an ellipse is it's a flattened circle. So imagine if I took the sides and went, okay? Or like a rubber band, and if I push these sides down, this is going to go out. So what it actually looks like is something more like that, okay? With Earth now there you go, there's Earth. So as you can see, it's not a perfect circle. That's what it means by being an ellipse. Now, how long does it take the Earth to go from right here all the way around? It takes 365 1/4 days. Well, how does that work? How can you have a fourth of a day? Well, we don't. This year, you may remember that we had February 29th. Most years, February only has 28 days. So after this year, when we get to 2021, February is only going to have 28 days in 2021. In 2022, it's going to have 28 days. In 2023, it's going to have 28 days. But on 2024, there's going to be another February 29th. So every 4 years, we add an extra day to February to take care of that fourth of a day. Because in 2021, we are at like 1/4 of an extra day. In 2022, we'd have 2/4 of an extra day. In 2023, we'd have 3/4 of a day. And in 2024, then, we're at 4/4 of a day, so we add February 29th to get us back to 0/4. We take that extra day and we add it into February. So, revolution, we've got two different words that are really close. We've got rotation and revolution. Rotation, we talked about, is simply the spinning of the Earth. Now, while the Earth is doing this, it's also going like this around the sun. You got to imagine the sun's in the middle. Okay, I'm spinning this the wrong way because it spins up towards the top, but it goes like that. Imagine the sun in the middle. My hand is the sun, and I got to move it a little bit. That's what revolution is. Revolution is my hand going like this. Rotation is the spinning. And both of those are important. The rotation is day and night. The revolution is part of the reason why we have seasons. The other part is Earth's tilted axis. Earth's axis is not straight up and down. It's tilted at an angle of 23.5 degrees. The tilt points in the same direction throughout Earth's orbit. And I'll explain that in a minute, but the first thing that I want to show you is when we have our globe, you can look at the axis. It goes from right here to right there. And if you look, it's not pointing straight up to the ceiling. It's pointing at that angle. Okay? If it were pointing straight up to the ceiling, it would look like this, and then our seasons would probably be different. Okay? Because it's that pointing that makes the temperature, why we have winter and summer, and why spring and fall are cooler than summer but warmer than winter, usually. Doesn't mean you can't have cold days or hot days. So, here's why. Earth's tilt causes sunlight to strike Earth at different angles. At any given time, each hemisphere or half of the Earth gets more or less sunlight. The seasons result from both Earth's tilted axis and its revolution around the sun. So, here's what I want to show you. I can get this to come down. There we go, it's moving. Try and get as much of this in as I can. So, if you look at this, I'm going to move this out of the way so you can see the whole screen. Earth's axis, I'm going to highlight it as best I can in each of these, always points in the same direction. You can see that if these arrows are always going in the same direction. And I'll show you this on the globe too. But if the sun is shining at these, you can see that this part of the Earth right here, if I draw a line, is closer than this part of the Earth. And in this one, the part closest to the Earth, it's all kind of right there. Same thing here, it's right there. On this one, if I draw a line kind of straight up and down, you can see that this part of the Earth right here is closer than this part right there. So it has to do with the tilt of the Earth. The sun's light is going to hit there, more going to hit there. Now what does that look like? Why does that work that way? Well, what it comes down to, again I'm going to mute that, is imagine that my table is the sun, okay? And this would be spring. If you look at the spring, I'm behind the sun, and my northern hemisphere, the top of my axis, is not pointed at the sun. If it was pointed at the sun, it would be pointed towards you on the screen. But it's not, it's pointed this way. So neither the northern hemisphere nor the southern hemisphere is pointing at the table. When I come here to summer, what you can see is that the top part of the globe is pointed at the table. This would be like going to fall. Neither the top nor the bottom are pointed at the table. They're pointed kind of off the sides. And when we go to winter, you can see that the southern hemisphere, the southern tip of the axis, is pointed towards the table while the northern hemisphere runs away from it. So here's how that works. What I'm going to do is I'm going to start right here. You can see this is North America. We're up here in North America. And what I'm going to do with the flashlight is I'm going to point it at, we have three special lines. Right here we have the equator, which is right where this line is. And it's hard to see, but right here we have something called the Tropic of Cancer. And down here, about the same distance away, we have the Tropic of Capricorn. And those are important because when the sun hits those lines, there's special days that are seasons of the year. So in the spring, the first day of spring, the light is hitting at the equator. Now, I'm going to try and keep my right hand as steady as I can. If you look, if we're in North Dakota, we're this far away from the equator. So the sun, most of the sun's direct light is hitting at the equator. When it goes to summer, so I'm going to turn. Now, mind you, I didn't move my right hand very much. And now the sun's direct light is going to point at the Tropic of Cancer, which is in Mexico. But look how much closer the flashlight is to North Dakota and the light. This is summer for us. We're getting more sun because the sun is closer to us. We're getting more intense light from the sun. In the fall, I think I spun that the wrong way. It should go that way. Yeah, it should go that way. So now we're back pointing at the equator. Again, I didn't move my right hand, and you can see that in the fall, we're not as close to the sun's direct light as we were in the summer. In the winter, the sun's light shines way down here at the Tropic of Capricorn. Get this lined up. And we're way up here. Look how much farther away we are from the sun. Here to there. So that's when winter happens. And then spring comes back and you're here again. And you can see that we should be getting warmer. So without both the revolution and the rotation, or excuse me, the revolution and the tilt of Earth's axis, we wouldn't have our seasons. Well, let me show you why that is. If this pointed straight up and down, it wouldn't matter. So, let me point it straight up and down. If I turn it, we're always just going to be at the equator. And if we're always pointing at the equator, then hypothetically your weather wouldn't change as much. So we might not have as bad a winter, but we also wouldn't have as warm of summers. So there's consequences to that. So now on to 363. We have 4 seasons. How does the Earth's tilt cause summer, fall, spring, and winter? This is pretty much just going to tell you what I told you. In June, the North Pole tilts toward the sun. Sunlight hits the northern hemisphere at steep angles. The light is more intense. It is summer. In December, the North Pole tilts away from the sun. Sunlight strikes the northern hemisphere at low angles. It is winter in the northern part of the world. In the southern hemisphere, however, it is summer. So, the point that I want to make there is simply that when it's summer for us, when we're facing towards the sun, and we have light from the sun hitting up here at the Tropic of Cancer, if you think about way down here, I'm going to tip this, if you look way down here at the bottom of South America, now it doesn't sit like this, the bottom of Argentina is way, way, way down here, really close to Antarctica. So think about if the sun is shining up here on the Tropic of Cancer, it's way far away from this part of South America down here. So it could be cold down there in winter, but it's summer here. Likewise, when the Earth is tilted this way, and the sun's light is shining on the Tropic of Capricorn, the sun's way down here. It's winter for us way up here because we're so far away. So when it's summer in the northern hemisphere, it's actually winter in the southern hemisphere. Northern hemisphere, north part, top part, southern hemisphere, bottom part of the world. Okay. So here's another thing that I kind of wanted to look at with you. Is when I was a kid, I used to think like, we got 4 seasons, I knew that, but we had summer. And for me, I always thought that summer was like June, July, and August. Because that's my summer break for school. And then I had fall, So that would make fall be September, October, and November. And then we had winter, which to me was December, January, and February. And then spring then would be March, April, and May. So, but that's not what it is. If you look, summer actually doesn't start till June 21st. Almost the whole month of June is actually in spring, 21 days of it. That leaves you only 9 days of summer in June. Summer actually runs all the way to September 22nd. And I know what you're saying, well, September 22nd, we're back in school, that kind of feels like fall. You're right, it does, but it's not technically fall. So there's like two different definitions of the seasons. Because I'm with you, June, July, and August are kind of our warm summer months. The fall actually goes from September 22nd to December 21st, almost all the way to Christmas. And you guys know, up here, Christmas feels a lot like winter. The end of November can feel a lot like winter. Heck, we had a giant blizzard in October. It felt like winter. So these are dependent on the Earth's tilt and where we are, okay? Winter actually runs from December 21st till March 20th. So all the way into March. And I know some of you are saying, well, March kind of feels more like spring. I know. And spring is actually March, April, the last part of March, April, May, and most of June. So the actual seasons are a little bit different than what they may seem. Okay. Come on, let's go to 364 and finish this section. All right. So this one talks about how does the sun's apparent path change over the seasons. And the apparent path is what the sun looks like when you go outside and look. So the diagram shows the apparent path of the sun during the day. Each yellow circle represents the sun's position at noon. How does that position change from winter to summer? The sun rises much higher into the sky during a summer day. It also rises earlier and sets later. And that's not a surprise. You know that summer days are longer. At the equator, the diagram does not apply to all parts of the world. Near the equator, the sun's apparent path changes much less during the year. Temperatures there change little. Come on. Oh, this thing. There we go. From season to season. All year long, sunlight strikes at a similar angle. At the equator, it's going to be warmer all year. This is the diagram that they were talking about. In the summer, the sun is going to rise and it's going to go way up high in the sky. In the spring and fall, like right now, it's getting a little bit higher in the sky than it did in the winter. In the winter, sometimes the sun barely gets up over the horizon. So, you know, if I were standing looking at the sun in the winter, I'd maybe have to lift my head a little bit. In the spring and fall, a little higher. In the summer, the sun's way up in the sky and I'd really have to look up. I don't recommend you look at the sun. In fact, do not look at the sun. But if you were going to look up to see where the sun was and not directly look at it, you'd have to look at a different angle to see it. So let's read that last paragraph and then I'll demonstrate this for you. At the poles, near the poles, the sun's apparent path is very different. Between seasons in northern Alaska, for instance, some summer nights are very short. During winters, the sun in the northern hemisphere, for instance, summer nights should be very long. Summer nights are very long in the northern hemisphere. During the winter, the sun hardly appears. So make predictions. The sun apparent path changes in the same pattern every year. Scientists use these patterns to make predictions. They can predict the exact times the sun will rise and set. That's how your calendars know. So here's how that works. Again, I got to get out my trusty tape and flashlight. I'm going to tape the string to the flashlight, and I'm going to tape the I'm going to tape this to North Dakota. Be way up here. So, right now it's spring. And if the sun was shining directly at the equator, try and get that perfect there. You can see my light there. We're looking at this angle. But watch when we go to summer. Oh, it came off. Bugger. Okay. In the summer, when we're pointed at the Tropic of Capricorn, it's much more direct. Now watch when I go to winter. Technology. In the winter, when we're pointed away, and at the Tropic of Capricorn, you can see that this goes way down, from here to here. If I bring this out straight, we'd have to drop down this much. Whereas in the summer, if I go from where North Dakota is out, it's much less of a drop. So that's how your vision of looking at where the sun would be changes. You're looking more down at the horizon. So anyway, that's the end of the video. A little bit longer science video. That was lesson 1 on the Earth and the Sun. I'm going to make this a discussion. Please tell me something that you learned, something that you thought was interesting, maybe something you didn't realize or know. Alright guys, have a great weekend.